Okay, guys. So welcome to our lecture on AI. Um, our presenters today will be me, Jeffrey, and my partner Ashwin. We're the workshop leads for this AI workshop, and I'm a cognitive science major and computer science major. If you guys want to reach out to us and talk about anything. And then our volunteer team is composed of Raf, Edmund, Nicole, and Lucy. So these will be our moderators and facilitators for today. So if you have any questions, feel free to reach to them in the chat. But they'll also be monitoring the chat in case you guys have any questions that come to Ashwin and I's attention. And so I guess before we start officially, I just want to go over some house or Zoom rules. So if you would like to ask a question or have a question, you can go ahead and raise your hand using the Zoom features, which I'm sure you guys may be familiar with. Just click on participants and then click on raise hand, and then one of our moderators, sorry, the names are wrong, will see that and then bring that to our attention or talk in the chat to answer your question. And then so just for our purposes as well, when a slide has these symbols, that kind of indicates that we're kind of looking for a response if you guys are comfortable with talking or talking in the chat. So you can go ahead and unmute your mic, answer the questions, or discuss anything we're going to be talking about. So it'd be super helpful for us and just make this hour that we have all the better. And then, so without further ado, I guess I'll start going into the overview for today. So we're going to be talking about what is artificial intelligence and what is machine learning. We're going to talk about the applications of AI and ML, artificial intelligence and machine learning. And something that we're interested in covering today in particular is talking about how does machine learning work. We hear these ideas all the time where it's like this new AI came out or new machine learning system came out. But really the question is how does it work, and what's what we're interested in. And if you were to pursue computer science or any tech field in the future, I feel like it's going to be really important to know kind of at least on a basic level how these machines work. Then we're going to go into a specific application of machine learning, which is facial recognition. So we're going to do a demo of that. And then lastly, we're going to do a little competition just so you guys can really apply the things that we learned today into a little game. So first off, what is artificial intelligence and machine learning? Does anyone have any ideas?
You guys get points if you answer. If you remember, you could win some cool prizes.
I'm not sure if this is correct, but is it like on the idea of creating human thoughts with computers? Yes.
Yeah, so that's pretty much it. So with artificial intelligence and machine learning, you're exactly right. We're trying to recreate human thoughts and how we do things ourselves into a machine. So really, the goal of artificial intelligence and machine learning is to simulate human intelligence and mimic human actions. And machine learning is a specific application of this. Of artificial intelligence that aims to give the systems the ability to automatically learn and improve from experience without being explicitly programmed. So we think of a computer, we tell it to do something, it's this. With machine learning, we're hoping to give it a bunch of data, stuff that it doesn't really know how to interpret, and then we're going to tell it, hey, do something with this. And it's learn from experience and know how to do future tasks without being explicitly told how to do it. So with that being said, does anyone know any examples of AI or ML that you've seen in your daily lives or anything else?
Does vending machines count?
Vending machines, you said?
Yeah.
Actually don't know, but I don't see why those super advanced ones don't have something like that programmed into them where they are able to learn something. I'm seeing in the chat driving cars. Yeah, that's a really good one. Tesla is amazing. It's crazy how much it can do by itself without human input. Yeah, Face ID for the phone for your iPhone is a really big one. So and spoiler, that's actually what we're going to be covering later today. So got ahead of ourselves. Instagram ads, yeah, that's a good one. Personalized marketing. And also the TikTok review page is pretty crazy. I don't know about you guys, but I watched like a couple videos and all of a sudden my entire For You page is littered with stuff that I want to watch. Yeah, so these are great examples. Is a big one. And on this slide, I show something that's pretty interesting. So the machine learning and artificial intelligence system, we start off with something like this, where it's trying to be a goalie, it completely misses pretty late. And then with a lot of learning and machine learning, we get to something like this, where it's able to sense the environment and be able to gauge how far it has to jump. And it's not really being explicitly programmed to do this. It kind of knows how to do this on its own. And David, I see you have a question. Did you want to unmute yourself or ask in the chat?
Can you hear me?
Yeah, we can. Yeah.
Oh, sometimes my microphone doesn't work. I've actually seen an example of, I've actually seen these videos about machine learning. There's like this guy who basically like uses machine learning to like beat video games, and like the AI, like he codes like machine learning. He codes the base for the machine learning, and then the AI kind of learns the game. And then eventually, after a few like phases, the AI can beat it with like fast speed.
Yeah, that's definitely a good example. And you have kind of the learning, something to be able to beat in a game, but then over time, it learns how to, be human, and it's pretty serious. This kind of,
I think Jeffrey, you're cutting out a little bit.
Okay. Oh, sorry, can you guys hear me? Ashwin?
We can kind of hear you.
Okay, cool.
You're like, yeah.
And then also we have something like this, where we have this company, Boston Dynamics. Unfortunately, not Tesla. So this is kind of one of its early trials, where a car is trying to learn how to drive in a parking lot, and it crashes into a cone pretty badly. And then, as someone mentioned before, we have something like Tesla, where if we did a lot of examples, able to completely drive on this road alone, and the driver isn't touching the wheel at all. Oh yeah, and Vanessa, if you'd like to share, please go ahead.
Okay, I wanted to say, I wanted to ask if Sophia the robot is an example of AI.
I'm familiar. Can you explain about Sophia?
Yeah, she's a robot that can design her to, she can perform like human functions. She was designed in I think Asia. I don't remember.
I think I've heard of that robot before. I think like the goal is to eventually have artificial intelligence. But right now, I'm not really sure if she has it. She just kind of looks human, right? She has like human skin or something like that.
Kind of. Not really.
I'm not exactly sure, but I don't think right now that's an example, just because they're still working on like making it look like a human, I feel. But I'm not exactly sure. I might be wrong.
Okay.
Thank you for sharing that. Yeah, and so I guess with all these examples, it's good to talk about, why is this even important? And I think it's pretty abundantly clear, if I haven't convinced you already, but we hopefully will. Because I think personally, this might be not something that everyone believes in, but I think we really are at the cusp of AI transforming our world as we know it. And in the coming years, AI, I feel like, will revolutionize many aspects of things that we've seen. We've already seen this with cars. I think we're going to see it with interactions between humans, robotics, and many fields will be really changed by AI. And so it's in our best interest to understand how we can use AI to its fullest and gain the most benefits out of this technology. And some common things that we don't really consider. Does anyone use Turnitin? Because those plagiarism checkers use AI to learn what phrases are copied and what phrases shouldn't be copied. For example, AI knows that common phrases like when you're saying, this means that blank, 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 that is plagiarism. But it knows that, phrases that, are kind of uncommon, where only a couple people would say, that is more likely to be plagiarism than others. And AI, your email system, it filters out what is spam and what isn't. So really, there's a lot of unknown applications or something that we don't really consider, but really it's going to transform our world. And so it's, hopefully we can teach you guys about these basic ideas. So without further ado, Ashwin will take it away now and start to explain, how we make a machine learning system, what it is, and really kind of the nitty gritty of it. So I think I'm cutting out a little bit, so I'll have Ashwin share his screen now.
Yeah, okay. Let me share my screen. Okay, can everyone see that, hopefully? Okay, cool.
Yeah, looks good.
Okay, so now we're gonna talk about how do we make a machine learning system. And in order to do that, let's think back to biology, which is what makes us smart. So let's think back to biology. Does anyone have any idea on what makes you and me smart? You can just say it or put it in the chat.
Isn't it like the neurons in our brains, how they connect with each other?
Yeah, exactly. Your brain, your neurons, those are all correct answers. So as you just said, a neuron is the basic building block of our brain. And the brain is made up of a bunch of small neurons, and working together, these neurons can make us, as smart as we are. So like Tony said, neurons form the basis of the brain. And the way neurons communicate is that signals are passed through these neurons from one to the other. So as you can see in this diagram right here, the neurons, one connection starts on the left and then it kind of goes all the way to the right and vice versa. So these neurons are constantly communicating with one another in our brain. So once again, like Tony said, the brain is made up of billions of neurons. I think it's, close to 100 billion. And the brain is divided into different groups. There's a part of the brain that works on vision. And then inside that part of the brain that works on vision, it's divided into even smaller segments of vision. And working together, the brain can do these amazing things. But keep in mind that the brain is divided into smaller and smaller parts, and that allows it to do all of the crazy things it does today. So in order to make artificial intelligence, let's just copy how the brain works, but just through a computer. So first, let's simulate a neuron. So in the actual brain, we have a neuron, but it's like biological, it's a cell. But in the computers, we obviously can't have that. So we use something called a node. And a node, it's very similar. It basically just takes all the inputs from its neighbors and then it adds them all together. And then based on that, then it either fires its signal or it doesn't fire its signal. So it's kind of an all or nothing response. And then, so we have one neuron, and then to build our artificial neural network, that's what we call our artificial brain. Then we're gonna add a bunch of nodes. And each of these nodes will be part of something that's responsible for a smaller thing. When we combine it all together, we'll be able to do pretty amazing tasks, just like an actual brain. So as you can see here, using all of our neurons together, we can compile an actual whole brain. As you can see in this image, we're using an artificial neural network to look at these bunch of pictures and figure out which they are. And as you can see, there's one layer that's focused on the texture, one layer that's focused on the color. And in reality, each of these layers are made up of neurons, and then we combine all the layers together. So we can actually classify something using all of the 4 properties. So now that we have a brain, what do we do next? Does anyone have an idea on what happens if we get a problem wrong?
Yeah, I think if you get a problem wrong, everything falls apart because they're all connected.
It is pretty bad when we get something wrong. But when you get something wrong, do you just like fall apart, or is there a way you can continue onwards?
Is there a way to catch the error?
There is a way to catch the error. Let's say there is. Okay, I'm seeing answers in the chat. We saying, yeah, we learn from it, we adjust from it, we adapt from it. Those are all great answers. And yeah, so just like we adapt when we, mess something up, a computer is also going to try and adapt when they mess something up. Sorry, I didn't switch the slide. So yeah, like you guys said, a lot of human intelligence is based on learning, right? Obviously, when we're babies, we're not like geniuses. But I feel like we're pretty smart now after we learned a bunch of stuff over our years. Okay, so our next question, how do humans learn? Is there like a particular way we try and learn? Yeah, experience, that's a good answer. Trial and error. Diagnose the problem and attempt to fix it. Yeah, these are all great answers. So trying to fix it, we try and fix it if we learn something and it doesn't work correctly. And exactly like that, through trial and error, that's how computers will learn, or artificial neural networks in this case. So what a artificial neural network does, which is just a fancy word for a fake brain, if it figures out that something is wrong, then it's going to adjust itself to make sure that it won't get it wrong next time. And if we do this for a bunch of times, if we give a bunch of data initially, our artificial neural network will become pretty smart, just like we become pretty smart if we have a lot of experience. All right, Jeffrey, this is you. Or do you guys have any questions before we move on?
I have a quick question regarding like how they classify stuff.
Yeah, go ahead.
So since they're like computers, right? How are we going to classify everything like with data? Like how do I classify, let's say how soft it is with numbers and stuff?
Okay, yeah, that's a good question. So the way it would typically work is you have like a sensor that would probably like exert force on something. And then based on how hard you would press, you could determine how soft something is. So if your sensor, if you press like a bunch and it doesn't move at all, it's probably pretty hard. But if you press and it moves a lot, it's probably pretty soft. That's one way you would do it. Good question.
Okay, thank you.
Anyone have any other questions? Okay, cool. Let's go to the next part, facial recognition.
All right, so hopefully my internet isn't too bad. Can you guys hear me? Okay, cool. So I will share my screen now. 1 second. Okay, and then I don't have it in presenter view, just so I can go to the demo. But essentially, now I want to talk about facial recognition because that's something I'm particularly interested in, and that's one application of artificial intelligence. And so one of you had mentioned, I forgot who it was, but the iPhone that we have now is able to classify faces. It knows my face from your face, from some random person's face. I can't get into my phone, and so it learns. So over time, Apple has given so much data to these systems where they're able to discriminate certain faces. So other than that, does anyone know examples of facial recognition we see in everyday life? Yeah, these are good ones. Cameras, security access. A lot of police footage nowadays uses facial recognition, yeah, identifying suspects in a crime. So, now even if you have a super blurry picture of someone committing a crime, if you show a machine learning system that picture, and then you give it a bunch of suspects, it's able to reasonably narrow it down to someone, or it's able to reasonably guess who that suspect was, or the correct person who committed the crime. Filters are a good one. It's able to adjust your face and then apply the filter on correctly. So yeah, these are really good examples. And I have an example of iPhone here again. The iPhone Bitmoji thing is really good. It's really good at this too. It's pretty accurate in copying the face of the woman here to the face of the fox. And so just a brief detour, talk facial recognition itself. It's a really, really complicated task that we're not really usually aware of. Facial processing is holistic in the sense that we can't process individual parts of the face without being influenced by the whole face. And this is this happens because we have a specific part of the brain that is dedicated to processing faces, and so the computers are generally able to detect a bunch of different features at a single point in time. We give it data. It tells us this eye is blank millimeters wide. It isn't able to judge how that eye is in relation to the nose, for example. So it's not really able to compare these different features of the face as well as humans are able to do. And one example of this facial holistic processing is example here. It's commonly known as the Thatcher effect, which some of you may have seen from a psych class or on TikTok. It's a pretty common effect. But basically here, if I show you these faces, one's a picture of a woman, one's a picture of Obama. And when we look at these faces, we're not influenced by the individual features, but we didn't even recognize, or hopefully you guys didn't recognize how skewed the face was. When you see these upside down, we see that it's a pretty normal face. When we flip it upside down, these features are actually really messed up. And so that's one example of how facial processing is really holistic and something that computers aren't really able to do. If you gave, for example, two pictures of Obama on the bottom right to a computer, if it isn't treated properly, it probably would be that those two people are two different people. But as we look at it, we can tell that that's a picture of Obama, and that's probably the same person. So traditionally computers are really good at doing many math computations in an instant. They can compare two photos pixel by pixel, but they're much worse at holistic processing, which is the point of facial recognition, why humans are so good at it. And so they can't see a photo like a human can, but it is able to compare a list of features instantly. And so that's kind of what we will get to in our activity, and really simulating a computer model. And for computers to process faces, need many examples and many features that help them discriminate one face from another. So you have heard that artificial intelligence, and machine learning requires a lot of big data, requires a lot of instances of when it's right and when it's wrong. That's really what allows it to be, what allows it to learn from examples. And so we have to start training it to understand how to look at all the features together. And so this is kind of a complex example. But as Ashwin mentioned before, the human visual system is separated to different specific functions where, this part of the visual system is dedicated to looking at light. This one's dedicated to looking at shadows, edges, and then you combine all these features together to get something high level where it's able to analyze holistic features like looking at the face as a whole, eyes and nose as a relationship with one another. And so that's what we're trying to do with our machine learning systems. And so now I'll go into a quick demo of this thing called Teachable Machine. So Google thankfully has pretty much a built-in machine learning system that we can use just to get an idea of how this works. So here I have the link open. So basically, if you guys wanted to do this at home, all you have to do is go into this link and get some data that you can start analyzing. So here I have pictures of Ashwin, which I'll give the system here. And then here I have pictures of myself. And you also don't need a bunch of pictures to do this. You can also do this with your webcam. So I'll give the system or the Google Teachable Machine some data of myself using the webcam here. So that just takes a bunch of pictures of my face that it's going to analyze. Then we just train the model, which Google will thankfully do for us. It's going to basically put all these pictures into the same processing model. Then it's going to discriminate certain features that separate me from Ashwin. And then it's going to learn from it. So it's going to, usually what happens is when you give it a data set like this, it's going to take some of the pictures, build a model around it, and then also use another portion of the pictures to test the model itself. So now it's while it was training, it was testing its model and how accurate it was, and then it was adjusting as Ashton mentioned before. As you can see here, it knows that this is clearly me, as you can see it by class 2, in my webcam here. And then I can also show a picture of Ashwin here. If I get close enough, it kind of knows that that's Ashwin. Obviously, the data would be a little bit better if we gave it more than 10 pictures. But yeah, so it knows it's Ashwin here. So that's just a cool example of that. Does anyone want to volunteer to put their face to it? I can take a picture of you if you're comfortable with that and show it on my phone, and I'll delete the picture after. Yeah, sure. Who was that?
Vanessa.
Okay, let me find your picture. Do you have your webcam on? Vanessa?
Vanessa, I think you're muted.
Yeah.
We need your webcam.
Do you want to turn your
on if
webcam so I can take a
Yeah.
quick
Oh,
photo?
okay. Okay. Let me go to it. Yeah, you can take the picture.
Right. Still loading for me. I can't see your video. I don't know if that's just me because my computer.
It might just be you. I can see you're fine.
Okay. You will get participation credit. Yeah, sorry, my computer is a little weird.
Okay, thank you.
Okay, so let's go back to slides. So yeah, that's just a cool example if you guys want to play around with it at home. I really encourage it because it really shows you how this works. And it's pretty cool demo to show your friends too, and your family. So yeah, so now let's build our own facial recognition models now that we have all this information. So now I'm going to be putting you guys into breakout rooms so that you can work with a workshop leader and as well as a small group to build your own models. So basically what will happen is that we're going to be working on certain worksheets. And so I'll go over a quick overview of the worksheet here, but your breakout room leader will also try to explain it. So if you can see my screen here, basically we're going to be seeing pictures of certain faces, person A, B, C, and D. You're going to, with your group members, highlight or write down the feature that describes this person. So if you see person A, they have medium hair, you can go ahead and bold this medium. You can write down their clothing color, hair color, etc. So this is the first part of activities, first table. You're going to be describing basically 4 people on this chart. And then in the second half of the activity, you're going to be training the model. So you're going to be seeing 3 unknown faces that are going to be partially obscured. You're going to be writing down the features that best describe that person. And then here in the similarity score, you're going to be adding up all of the matches between person 1 and person A, A through D. And then that will be the similarity score. And that will be kind of your best guess for who that person is based on our model. So again, hopefully your breakout leader will explain this as well and give you the worksheet. But let me go ahead and make the breakout rooms. 1 second. All right. Sorry for the end to your breakout room. We're running a little bit behind, so I'm actually going to cut out the second half activity. But I will leave that as a challenge to you guys because I think it's a pretty instructive activity. But for a quick discussion, just feel free to unmute yourselves. But were some features more important than others? How do you find the activity overall?
It can be. Because if you are comparing like facial features, if you are comparing 2 people with brown eyes and a person with blue eyes, the blue eyes person stands out.
Definitely, that's a good answer. I see in the someone else eye color as well. What were the most important? I think eye color was an important one.
I would say Josh.
Is there any way you would? guess to add a model to be more accurate, cut someone off.
Yeah, Raymond said jaw shape. Oh, sorry, I did it again.
Yeah, that's perfect. And then last, how do you model would perform if you were given more images for 2 pictures of you in the beginning?
I think you can add more characteristics.
Yeah, so you can add characteristics to our model better. We're also given images in the beginning. So Tony, Nessa mentioned, might be more accurate because you have more data from, and the whole point of AI, a lot of data. In this case, we're doing of a crude example, just to get across, just models. And so off with the first that we talked about, it's that we quickly talk about something called weights. So we're already over time, so no more than 4 minutes. But are essentially, we scale the certain features. And a quick example, let's say this guy, does anyone have a name? Just really quickly. Or gal,
Ryan.
Bob. We here. Let's say Bob is, just meet this guy. He's a pretty neutral. We wouldn't say he's bad. We just met him. He's okay. Let's say he has money and charity. We would move his data meter up to. We'd say, he's a person. Let's say find out that he hurt someone in the past. Then we say really bad. The weight of him being is much more than the weight of him back to charity. But then it influences all the way to the bottom. And so that's the idea of where some statistics and are way more than others, only slightly more than others. And so in neural, we have these things called nodes mentioned. These nodes usually have attached to their tells how important it is. When we train our model, when we do something, that's kind of where we investments. When we learn, say clothing color isn't as people can change from day to day. We would wait all the way down, because in recognition of whose face. And so we used to have a second where we go a more difficult with recognition, but unfortunately we for that. So I recommend that you guys slides and video because it's an activity where we do the same concept. They're attached to them. These be similar, but some features give them more weight if you discriminate. Here's lastly machine learning doing these went on the they look very similar. Same. This machine learning be able to directly predict whose was pretty, confidence of about % for most of the time. And yeah, recap, we what is intelligence and what is learning. Talk about the application in ML. We got a quick example of machine learning work. In your to identifiers and use those to guess who's facing an unknown face. So that's kind of what a instantaneous moment. Continuously, when your photo, it's able, all those features in, and then it uses features to get whose face it is an unknown feature. And so this will also be here's some resources if you're interested. And then you guys are free to. Thanks for coming and your participation.
Yeah, thanks for coming, everyone. If you have any questions, just drop them in the chat, or you can ask them right now, or you can reach out to us later. But yeah, thanks for showing up.